Alright, so here is a video on how to solve compound inequalities. So let's take a look at our first example. So we have solve and graph this compound inequality. The OR problems are probably the easiest because they're the most straightforward. They will always have the word OR, so all you have to do is solve this one separately, solve this one separately, and get an answer. Okay? So if you want, kind of draw a little line down the middle so you know what to do on which problem. So the first problem on the left, I would subtract 6 from both sides. I would get negative 6v is greater than or equal to 36. I would divide by negative 6 on both sides. Now when I divide by a negative, your inequality sign flips. Those rules still apply. And then I would get negative 6. So that's the first one. I'm going to drop down that word OR. Okay, you need to have and or in your problem at least. On the second problem, I would subtract 8. I would get 7v is greater than or equal to 54. 6. Then I would divide by 7. To get 8. So now I would graph that inequality. I know ORs are going to go opposite directions, so I'm going to start with this negative 6, and it is closed in, and it is shaded to the left. And then I'm going to start with that 8, which is closed in also, and shade to the right. Okay? So my answer would be v has to be less than or equal to negative 6, or v has to be greater than or equal to 8. And then here is my solution. I know it looks right because it's an OR problem and my arrows are going opposite directions. Okay? So those are how you do OR problems. Let's look at some AND problems. In this one, they gave us the word AND, so it's kind of like the one we did before. We're going to solve both problems separately. Okay? So go ahead and try solving this one on your own and this one on your own, and I'll show your answer in a second. Problem, I subtracted 6 on both sides, got negative 70. I divided by a positive 7, so my sign did not flip, and I got negative 10. I brought down the word AND. I added 7 to both sides to get 16, divided by negative 2, which means my sign flips. So my answer is n is greater than negative 10, and n has to be less than negative 8. So I know it's an AND problem. So I went over to this negative 10, and it went to the right. I went to the negative 8, and it was also open, and I went to the left. So this makes sense because that AND problem is shaded in between. Okay? So once again, if they give you the word AND or OR in the middle of the problem, that just means you solve each problem separately. Okay? So it's just twice as much work as we're used to. Now, here is an AND problem that looks a little differently, and we're going to solve them differently. So when they're all smushed together, I know that is an AND problem. Okay, so I know my graph, it's probably going to look something like this with an open and a closed and shade in between, but I don't know yet. So kind of a head start on how you would think about this problem. Don't write this down right now, but if you would ignore this left side of the problem, there's a normal two-step problem that you would know how to solve. Okay, so the first thing I do is subtract 9. So if you're ever confused on what to do first, you can cover up that left side. Okay, so I would subtract 9. Okay, if you do it in the middle, you have to do it to the right side and to the left side. So I'm going to subtract 9 on this side and subtract 9 on that left side. Okay, then I'm going to cross out my 9s. 45 minus 9 is going to give us 36, and then 72 minus 9 is going to give us 63. Okay, so now I need to bring down the rest of my problem. I'm going to bring down this less than sign, bring down this less than or equal to sign, and then bring down this middle term that I didn't use. Okay, once again, ignore this left side if you can't tell what to do, but I need to get the 9 or the negative 9 away by dividing. Once again, if you do it to the middle, you need to do it to both sides. Okay? You did divide by a negative, so you do have to flip your signs. I'm left with v in the middle, and then 36 divided by negative 9 is negative 4. 63 divided by negative 9 is a negative 7. Okay? So here is my final answer. Notice the signs were going the opposite way, and we're used to them always being opening to the right. The reason that is here's our bigger number, because negative 4 is the most less. So if you wanted to, you could put negative 4 here, you could put negative 7 here with a v, and then you would just have to make sure your inequality signs matched up. Okay. Maybe on a multiple choice test you would see it written this way, so they're both the exact same thing. So this is an and problem, so we're going to shade in between. So notice that the sign with the 7 was closed in, so I'm going to go to negative 7 and close it in. And then notice the sign with the negative 4 is open, so I'm going to go to this negative 4 and leave it open. Okay. Once again, it's an and problem, so we're going to shade in between. Okay? So those are how you solve and problems that are smushed together. Okay? Let's look at another example. How about you try this one? So try this one, press pause, and then I will show the answer in a second. So here's what I got in the box, the red answer. I subtracted 4 on all sides to get negative 56 and negative 32. I finally divided by negative 8. Don't forget that is a negative 8 sign. So when you divide by a negative 8, you're going to flip your signs and then get a positive 7 and a positive 4. Notice our signs are kind of facing to the right. That's because our bigger number was on the left. So you don't have to do this, but I just like to do it because I'm more of a visual person when they're all facing this way. So I put the bigger number 7, the smaller number 4, and I matched up my inequality signs. And then I graphed it, so it was closed on a 4, closed on a 7, and shaded in between. Okay. So moving on, we've got the challenging problems. Okay. So these are the most challenging problems that you're ever gonna come across with compound inequalities. So this is an and problem. So typically with and problems, we start in the middle and do it to both sides. But notice there's no variable in the middle. So when there's no variable in the middle, we cannot do like we've done before. So we have to write two problems. Okay, so the first problem you can probably see pretty easy. It's going to be 10 plus 5x is less than 50. Okay, all I did was I recopied what was on the left and the right of that inequality sign. To find your second problem, it's going to be including that middle again, but the other side. So 50 is less than 8x plus 2. And since this was an and problem, I am going to write the word and in between. And now you just solve it like you've been doing. So maybe the hardest part is just setting up those problems. Okay, so if there is no variable in the middle, you're going to have to rewrite one problem on the right, one problem on the left, and solve them both the same way. So I would start off by subtracting 10. 5x is less than 40. Divide by 5. X is going to be less than 8. Okay, hop over to this next problem. Just kidding, that should be a 5. No, it should be an 8. Alright, I would subtract 2. 48 is less than 8x. Divide by 8. Not the x, sorry. 6 is less than x. Okay, remember my variable can't be on that right side, so that's the same as x is greater than 6. Okay, so my final answer, drop down my and, will be this whole thing down here. So x has to be less than an 8 and it has to be greater than a 6. Let's practice writing that as an inequality without the word and. So again, my bigger number is going to go on the right. My smaller number is going to go on the left with the x in the middle. the sign was opening up to the 8, so it's going to continue to do that, and then the sign was opening to the x, so it would continue to do that. Okay, so that's another way you can write that without the word and. So now I'm going to graph it. It would be a 6 open, 8 open, and shaded in between. Okay, so not that bad, just double the work because you have to kind of separate the problems as well. All right, one more final problem. The last challenging problem we will ever come across. Okay, so notice I do have an x in the middle, but I've got variables on the left and variables on the right. And we know with variables on both sides, we have to move variables to the same side, and I can't do that when I have an and problem all like this. So we're going to have to rewrite the problem like we did before. So here is the first problem. 1 plus 3x is less than 4x plus 8. Our second problem, still going to include that middle. So 4x plus 8 is less than or equal to 8 plus x. Okay, now that I've got two separate problems, I'm going to put the word and in between, and I'm going to solve them like in the past with variables on both sides. So I'm going to move my x's to the left side first. I would get 1, and that would be a negative 1x is less than 8. Subtract 8.
Call the main office, please.
Negative 1x is less than 7. Divide by negative 1. So I'm going to flip my sign and get negative 7. You go ahead and bring down the word and if we want to. Then I've got this other problem where I'm going to subtract x and bring it over here. We all know that's the same as a 1x. So it would be 3x plus 8 is less than or equal to 8. Subtract 8 on both sides. This would be 0 is greater than or equal to 3x. Keep going and divide by 3, and you would get x is less than or equal to 0. Okay, so here is my final answer. X has to be greater than a negative 7 and less than or equal to a 0. Let's practice writing that without the word and. Again, 0 is my larger number. Negative 7 is a smaller number with the x in the middle. The 0 had a less than or equal to sign, and then with the negative 7, it was opening up to the x. Okay. Lastly, to graph that, I would go at a negative 7. It would be open. I would go to a 0. It would be closed in. And then I would shade in between. Okay. So that is how you would solve the most challenging compound inequality. It's when there's x's on all the sides, the left, right, and the middle. Again, you just need to rewrite the problem and solve it two separate ways. Okay? So those are how you solve compound inequalities. So now you get to practice your IXL. First, I want you to do K15 because that's graphing solutions. K14 is just solving but not graphing. So I want you to graph first. So try K15, get it to an 85, and then try K14 and get it to an 85. So thank you for watching How to Solve Compound Inequalities. Get started.